My name is Marc Schoechlin. I'm a site reliability engineer of the open source project Sovereign Cloud Stack. Probably you ever heard about that. I'm working as a full-time employee for the OSB Alliance. That's an association which tries to foster the adoption of open source technologies better in the industry in Germany and in the cloud service provider industry and in general. And I'm very glad to be here. I entered the project at October last year, and I'm relatively new to the open networking area, to that area of engineering, and I want to show you. I want to give you an introduction. What are we doing in the Sovereign Cloud Stack project? What are our targets regarding open networking? So, what's Sovereign Cloud Stack? Sovereign Cloud Stack is a solution where you can run your own cloud platform. From the perspective of a cloud service provider, beyond the hyperscalers like AWS, Azure, and Google, and so on. But you can also run that solution in your private cloud on your own data center. We are pretty focused on control of data. We try to build a decentralized, standardized, and federated cloud and container platform, including storage and all the commodity services you know from the typical cloud environments. We are trying to provide true digital sovereignty. The hyperscalers also discovered that expression, digital sovereignty, but our understanding is a bit more wider. We are trying to provide a platform which provides you the possibility to do innovation, to develop that platform, and from a user's perspective, from a cloud service provider's perspective, we are providing a platform which reduces your technical, economic, strategical, and legal dependencies to vendors. Nevertheless, it's up to you. You can find the right provider which is providing a sovereign cloud stack environment. You can run it at your own data center, and you can do all together. You can have multiple cloud platforms which behave in the same way. So, what are we? We are a vital open source project. What means vital? We have a full-time employee team of 30 persons. We have around 50 engineers which are doing a continuous development on that platform, which are paid by the German Ministry of Economic Affairs with 14 million euros over 3 years. And we are now running in the third and last year of that phase, and we managed to build up a vital platform in that way that we still have cloud service providers and private providers which adopted our technology. And we have an open calendar. You can just join our session whenever you want and whenever you want to contribute something. We are built on giants. We combine the proven and robust cloud technologies to a uniform standard. We are using OpenStack, Ceph, Kubernetes, and so on, and now also Sonic. And the users of that cloud platform, it does not matter if you run a private cloud or a public cloud, find the same conditions, same namings of base images, the same APIs. You can just move your workload between different vendors, different providers. You can just use it. And the providers use their narrow engineering capacities for the things that make the difference by sharing technologies and having a community of practice. That means we are providing a ready-to-use environment, and you just can deploy it at your data center. There are manuals which describe how to deploy it and how to use it. But your engineers can do, for example, upstream work in Sonic, in OpenStack, and so on. And that helps you to get a deep understanding and a good capability to solve problems. Sovereign Cloud Stack, this is the last Sovereign Cloud Stack introduction slide. Sovereign Cloud Stack bases on 3 foundations. The modular open source reference implementation, it's called OSISM. It's the technology you can use, but it's not necessary that you really use that implementation. You can also use another OpenStack flavor or another Kubernetes flavor. But we also have these certifiable standards. We defined standards which can be checked in an automated way. And if you already have an OpenStack cloud, it's possible to check your cloud against these standards and get the Sovereign Cloud Stack certificate, for example. And this helps users to understand, can I migrate my workload between different vendors, different providers? And the third base is we share operational knowledge. We not just only provide the technology, we also have community meetings, we have periodic discussions between cloud service providers, operators. How do you do your networking? How do you implement specific things? And this also helps to increase your speed in adoption of new technologies. So, what is our motivation for open networking? When you use the traditional vendors of data center switching hardware, you have many different network operating systems. They behave differently but provide a lot of features which are comparable. But from our perspective, it's not ideal because in a cloud service provider environment, it's automation and industrialization is key. You have to manage to deploy new switches, new boxes every day to manage the entire life cycle in an automated way. So this is really important for us to have a common interface to use that system in the same way, to just build a single type of automation and not for different vendors. Open design and open implementation provides us the ability to analyze, understand, and solve problems in depth. Whenever we get in a problem, or if we want to do an architectural decision as a service provider or also as an open source project, we can just look at the source. What's going on there? How is it implemented? Is it good enough for us? Do we need to extend it? And this is a very powerful thing also for adapter, because you have the ability to fully understand if you have enough time or enough resources. If you don't have it, you can use support contracts or consulting services, but sometimes it's very important from a strategic view to completely understand what you are doing or what the problem currently is. Open design also enables the addition and improvement of needed functions, offers the possibility to purchase hardware from different manufacturers. Manufacturers are changing their prices, the specification of the hardware. And if you have a common network operating system, you don't have to throw away your automation. You can just continue to use it. And this is really, really interesting from a cloud service provider view. And the last point, this open design and open implementation also provides you the possibility to use the same technologies on different points in your infrastructure. One example is using FRR routing on nodes, on compute nodes of OpenStack, and also on switches. And you can use the same automation. You can use the same mechanisms to manage these systems. Another motivation is also, other motivations are also, vital open source community also provides an ecosystem of developers, users, and support mechanisms. You have the choice which provider should help you. You have the choice if you miss something in the implementation to make a contract with a company which does a custom implementation for you, which will be upstream in future. So you don't have the problem to support it forever or to maintain it forever. The vendor independence is also important about the knowledge of the product itself, and the strategy is not gatekept anymore. If you have a proprietary network operating system, some things are not understandable by you. You don't have the source. You cannot build a training ecosystem if you don't have access for all the resources. So also, I already said problems, new solutions can be accessible with a temporary fork. You can just build your own sonic flavor. You can try to get it upstream, but in the meantime, you can just use it with your own build. So it's a limited time for the support of that internal solution. The strategy of the solution is subject of the needs of the users and is shaped by those who contribute. As you all observed with VMware, sometimes companies decide to change their strategy. If you are using an open source system, you have the possibility to continue to fork. You can add the features which are needed by you, and not that the features are not filtered out if it's not in the strategy of the vendor. In-house experts with powerful capabilities can be established in the way that never can do with a proprietary product. They can start, if it's really, really important for us and you are doing a lot of networking, you can build up your own Sonic developer team, and they create Sonic upstream patches, fixes for all the things which are problematic for you. That's something new. And open technologies and standards facilitate adoption of our project because we can document blueprints, we can create documentation about how to set up a sovereign cloud stack cloud in a reproducible way. Typically, this is not possible with closed source software because other vendors are upset about the fact that you only document a certain operating system, and sometimes also this just changes. So, in the CSP environment, Sonic is very attractive because it has a proven track record. It's easier to support and manage within a consuming organization compared to the fact that if you use multiple network operating systems in your company, you just have that single system, and you just have to focus on that single system. It supports a wide range of vendors, switches and ASICs, and you can have a flexible usage of devices from different vendors. You can also add your own specific things, and yeah. And finally, it's Debian based, but I think the most important thing, you're breaking down the barriers between the networking team and the cloud service operator team or the compute team. They both start to understand Linux, use the mechanisms for Linux, for example, Ansible automation, or they can discuss in a new way. They are understanding each other in a better way. Our opportunities for the futures are, we are currently starting to improve support for Sonic and Soaring Cloud Stack. We strongly focus on simplified provisioning, configuration management, and powerful and holistic automation of devices. What means that? We want to automate everything in the life cycle of such a switch or such a network equipment. The provisioning or the installation of the Sonic image, and the deprovisioning, the configuration, yeah, everything. We can seamlessly integrate it in our overall system, and we are starting to improve the ML2 plugin. I will come to that point later. We are improving the integration for automation of the day-by-day configuration. We want to leverage the Sonic to improve the software-defined network scalability in SCS. Currently, layer 3 underlays are a big cultural change for many cloud service provider teams if you are not working at AWS or Google or so on. You need a new understanding, and it's difficult to get in that area to understand everything. And our job is to provide a good setup, to provide good documentation about how to set up a cloud with Sonic layer 3 underlay. So we also are trying to add new Sonic features, for example, for the Geneve network isolation, abstraction, tunneling, and load balancing. So our motivation for building our own Sonic images was just to learn, to get a deeper understanding of Sonic, to know, to get the capability to interact with the upstream community, and to fastly integrate the current development status, and to have the possibility to adopt. As an open source project, we are pretty focused on open technologies, so therefore this is our first class member. Our learnings and takeaways our community and enterprise version have both issues on our purchase environments. I'm currently in progress to build up a test data center, a test cloud platform, and we found smaller problems, and we found that also on enterprise image, but not very dramatic things. But this needs to improve in future. We are enthusiastic supporters of Sonic in general, but as I described, Sonic needs some love in quality assurance. I think this will also get better if Sonic is more adopted in the open source community. It's more widespread. So we also have possible drawbacks for Sonic community. It's hard to support if you are not purchasing commercial support, if you don't want to spend to build up your own experts in-house. So this is important. Naturally, manufacturers have a deeper understanding of the details of the hardware. So when it comes to hardware-related topics, the manufacturers have naturally a better understanding. Possible drawbacks of both variants are we are enthusiastic supporters, but Sonic needs a little bit more love in the quality assurance area. But there are signs that it's getting better. And it should be more adopted. I'm a little bit out of time, so I'm sorry. What are we planning for the future? We try to establish a layer 3 underlay. We use eBGP unnumbered with 4-byte ASNs. We will adopt VXLAN and eVPN for tenant separation in OpenStack to separate the customers. And we want to enhance the SmartNICs and DPUs. We want to improve the support for SmartNICs and DPUs in our stack. We are targeting to do an extension in the ML2 agent. This helps to do the deep automation and the deep orchestration of the cloud platform. And here you can see some networks setups we designed as our next steps. At the first, we are doing a typical leaf spine setup with a layer 2 to the servers. And we are using the Newton node to route over VXLAN and BGP routing daemons the traffic. So this works good for 100 to 1,000 tenants. We are using that eBGP. And possibly the Newton node can become a choke point because of the east-west and north-south traffic is routed through it. Our final solution is another network design is to bring VXLAN directly to the servers. So we run a BGP FFR daemon directly on the servers, and we are establishing VXLANs between the servers. This scales much better with more than 1,000 tenants, and we the switches in the spine, or the switches in general, just doing a basic layer 3 routing and don't need to know so much about the VXLAN. And our target design is to combine these two architectures to provide the possibility to do that termination of the network traffic over over FFR on the server side, and also provide the possibility to add bare metal servers to a setup. Sometimes this is necessary, especially for private clouds, to also provide the possibility to run or to use bare metal nodes in the network setup. So I shortened the last three slides a little bit. So our future objectives are provide a good Sonic integration and support SCS deployments, make network scalability and performance easily accessible, direct integration of rollout and configuration of the network, improve the support for SmartNICs and DPUs, support bare metal, and we also targeting improvements for interconnecting sovereign cloud stack clouds. And our next evolutionary steps are automatic the deployment of Sonic switches, do dynamic configuration via OpenStack using the ML2 agent. Maybe, but we are not sure, move the network control plane from a dedicated network node to the Sonic switches. We are currently not really sure if that works, but we will try it. And improve for SmartNIC and DPU support and host orchestration for BGP and EVPN. So that's it. If you are interested in the Soaring Cloud Stack project, join our SCS Summit in Berlin at May the 14th. You can understand, you get a good overview about the strategic things of SCS. And at the following day, there's the Open Infra Day, so you're getting a little bit more in detail on that day. So that's it. Sorry for extending the presentation time.
Thank you. Any questions? Any questions before we go for a beer? I'm kidding. Thank you.